Hey guys, Mr. Riz, and I'm going to help you going over the second quarterly exam review. This video is going to have both parts. There we go. Hopefully not too much, but and just to help you guys through this. So let's start off with the first question here. So if f of x equals negative x squared plus x, which of the following will calculate the derivative? So first off, it's either between a or b because we need to have, actually it should be going towards 0. So it's technically neither one of those, but it should be going towards 0. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So the answer would be B, because this one here, it replaced both the x in the x squared and the x with the x plus delta x. This one here just puts an x plus delta x at the end, so it would be B. Moving on to number 2 here, which equation will find the tangent line of the graph at the point where x equals 1? So we could do the limit here, but it'd probably be a little bit easier to use the shortcuts that we know. To find the tangent line here, we need to find the derivative. So f prime of x would equal negative 4x plus 2. That's it. And we got to plug in 1 now for x. So f prime of 1 would be whatever negative 4 times 1 plus 2 is, and that would be negative 2, and that's our slope. So with y equals mx plus b, we know that our y, or actually our m is negative 2 and our x is 1. We got to find our y by plugging it back into the original equation. And let's see, if we plug 1 back into this, this would be negative 2 plus 3, and so y would have been 3. Let's solve for b now. So this would be negative 2 we'd add over, and that would be 5. And so the equation is y equals negative 2x plus 5. Do we have that anywhere here? And we would here for D. If we take this negative 2 and move it over, it would equal 5. So number 2 is D. Number 3, find the points in the graph where it has a slope of 3. So if we want to find the slope, we take the derivative. We're going to set it equal to 3. All right, the derivative would be of x cubed would be 3x squared, and then the minus 2 goes away. So when does 3x squared equal 3? Well, that's when x squared would equal 1, and so that's when x equals plus or minus 1. So it's going to be not C or D. What we got to do is either A or B, and we're going to have to plug both 1 and negative 1 back into the original problem. So 1 cubed is 1 minus 2 is negative 1. Negative 1 cubed is negative 1 minus 2 is negative 3. So the answer should be B. All right, number 4, what's the slope of the tangent line to the graph? So to find the slope of the tangent line, we take the derivative of negative 2x squared would be negative 4x. That'd be it, the 7 goes away. And we're going to plug in the x value. So f prime of negative 2 would be negative 4 times negative 2, and that would be 8. That's choice A. Find the derivative. All right, we know that's some basic power rule. We multiply the 6 times the 1 in front, drop it down a power, so that would be B, 6x to the 5th, piece of cake. Find the derivative of this one. We can treat them separately. First off, 5x squared would go to 10x, and the derivative of cosine would be negative sine, so it should be 10x minus 3 sine of x, so that's choice C. Derivative, all right, 5x to the 3rd, that'd be 15x squared plus 2 sine goes to cosine, so it'd be negative 15, that'd be C. Negative 15x squared plus 2 cosine x. Ooh, okay, what about this one here? Now, 3 over x to the 4th is not 3 over 3x squared. That would be 3x to the negative 4th. And we got to figure out when x equals 8. Okay, so the answer to this one here, let's see, 3 times negative 4 is negative 12, x to the negative 5th. So this is negative 12 over x to the 5th power. All right, so whatever 8 to the 5th power is, 8 to the 5th, looking at my calculator, is negative 12 over 32,768. I'm going to see if that reduces. So negative 12 divided by that comes out a word decimal. I'll press math, enter, enter on my calculator, and that is choice C, negative 3 over 8192. All right, find the slope of the graph. All right, so we got to take the derivative of this. Now this is a chain rule problem because we have a function inside of another. So something squared would be 2 of that something to the first power. And then we times by the derivative of the inside is -5. So really this becomes -10 times -5x minus 3. What we need to do now is plug in 5 to find the slope. So what's -10 times -5 times 5 minus 3? What's -10 times? That'd be -25 minus 3, -28. -10 times you know what? I started writing the answer down before you. -10 times -28 is a positive 280. All right, we got another chain rule problem. So -4 of something squared. Multiply the -4 times the 2. So this would be -8 of the inside to the first power. And we times by the derivative of the inside, which would be -3. So this is 24 times -3x plus 5. Just like the last problem now, we're going to plug in 4 for x. -3 times 4 plus 5. So let's see, this would be 24 times -12 plus 5. That's -7. All right, that would be what? I'm going to just double check this here. -168. Yeah, that's one of our choices. Remember, if I'm going too fast, just pause the video and move along. Here we go. Find the slope of the line. All right, so let's change this to 2x squared plus 9x minus 7x to the -2nd. I don't like the way that looks, so I'm going to change it before I take the derivative. All right, the derivative of this would be 4x plus 9, then plus 14x to the -3rd, or 4x plus 9 plus 14 over x cubed. All right, now that we got that, we're going to plug in -4. So what's 4 times -4 plus 9 plus 14 over -4 cubed? All right, see, this would be -16 plus 9. What's that, 7? Or -7. And then 14 divided by 4, -4 cubed is a probably doesn't come out right, -7 over 32. All right, so what's -7 minus 7 divided by 32? Math, enter. On our calculator here, it would be a -231 over 32. You can get decimals, just double check to see what the decimals equal here. All right, next we got a product rule here. Well, we could do product rule, but since that's a plain old x, let's distribute that. Make this a 2x to the 4th plus 9x. Then we'll take the derivative of it. The derivative of that would be 8x cubed plus 9, and we'll plug in 5. So what's 8 times 5 cubed plus 9? It's going to be fairly large. All right, 5 to the 3rd power is 125. We times that by 8, that's 1,000 plus 9. That should be choice C. All right, find the slope. Okay, let's see. Well, ain't much we can do with those, so we'll just take the derivative. This be 4/5 z to the -1/5 power, and then minus 7/8 z to the -1/8 power. So this would be 4 over 5 z to the 1/5 power. If we put that on the denominator, minus 7 over 8 z to the 1/8 power. So all we need to do now is to replace all our z's with 6, and that should look like that one. Yeah, that one's pretty close. Okay, that's definitely not that. They're not negative on the bottom. And that one has a 7. Oh, that has a plus sign in between, so that'd be choice A. Determine any values, if any, or determine all values of x, if any, when the graph has a horizontal tangent. So to find horizontal tangents, we've done this a lot. It's when the derivative equals 0. So let's take the derivative. This would be 3x squared plus 12x. Figure out when does that equal 0. Okay, we could factor out a 3x and make this an x plus 4. If we solve both of those, okay, when does 3x equal 0? Well, that's when x equals 0. When does x plus 4 equal 0? Well, that's when x equals negative 4. So we got two answers here at 0 and negative 4. Choice B. Piece of cake. All right, another horizontal tangent problem. So let's do that same steps again. We'll take the derivative, which would be 4x cubed minus 500. I'm going to set it equal to 0. All right, to solve this one here, let's move the 500 over. We can divide by 4. That would be, what, 125? And then take the cube root of that. The cube root of 125 comes out just to be 5, so that would be D. All right, find dy dx. So we're trying to find the derivative. Now this problem here, we look, it's a toughie because we have x cubed times the square root. So this is going to be x cubed times x plus 1 to the 1/2 power. So we got to do product rule and the chain rule together. So let's do the product rule first. So we'd have a 3x squared. We'll leave the x to the 1/2 power alone. Plus, now we'll leave the x cubed alone, and we'll take the derivative of something to the 1/2 power. So that'd be 1/2 of that something to the negative 1/2 power. And if we times by the derivative of the inside, which would just be 1. All right, so we need to make this a whole lot better here. What can we do to these problems here? Well, we could factor out the x to the negative 1/2 power. So let's factor that out. X plus 1 to the negative 1/2 power. So if we do that from this becomes 3x squared times x plus 1 to the first power. And this just becomes 1/2 x cubed. All right, so let's distribute this here. That'd be 3x cubed plus 3x squared and plus 1/2 x cubed. And this would be all over radical x plus 1. If we move this down to the bottom because it's negative, and it's in the square root because it's 1/2. So let's see, this would be 3 plus 1/2. That's 7/2 x cubed plus 3x squared. Okay. Any of those answers looking like that? Kind of looking like this one here. And if we factor out a 1/2 or divide everything by 2, factor that out, this would become 7x cubed, and then plus, let's see, if we divide, that should be 6x squared. Oh, actually, I'm seeing it's more actually looking like B here, because then we could factor out the x squared from the top, and the choice for that problem would be B. All right, next. If P of x equals f of x times g of x, find P of 8. So we got to do the product rule. So we're going to do f prime of 8 times g of 8 plus f of 8 times g prime of 8. So let's look at 8 here. We got a spot there and spot there. So the primes means the slope. The regulars mean the y location, or how high it is. So what's the slope of this line here? That's 1. What's the y value of 8 of g? That looks like to be 4. All right, next, what's the y value of 8? I would say that's 7. What's the slope of that? I would say that's negative 1. So what's 4 minus 7? That would be negative 3. Choice A. All right, next, the product rule. Okay, so if we use the product rule, derivative of t to the negative 4, that'd be negative 4t to the negative 5th. All right, we leave the sign of t alone. And then plus, now we'll leave the t to the negative 4th power alone. The derivative sign of t is the cosine of t. All right, which one of these matches that answer here? Let's see. Well, just B, right? Yep, B would be the only one that matches. All right, product rule, same thing here. All right, so let's take the derivative of that. It would be negative 3t to the negative 4th power. We'll leave the cosine alone. And then we're going to go ahead plus. We'll leave the t to the negative 3 alone. The derivative of cosine is negative sine. So we should have both things negative. So what matches this? All right, it would be close to this one. It's either A or B. It would be B because we need to have a negative t to the negative third power sine of t. All right, see how well the answer key's set up. Doing okay. 19 out of 19. Okay, so there's part one. Let's go ahead and do part two next, just so we can go through this here all together in one video. All right, let's preview it. Two. All right, find the derivative. Ooh, okay, we have to do product rule here. So the derivative of 3e to the x is 3e to the x. We'll leave the cosine alone. Then we'll leave the 3e to the x alone. Derivative of cosine is negative sine. All right, so the only answer here would be B, because we could factor out this 3e to the x and we'd have a cosine minus sine. That would be choice B. All right, next question here. Okay, we could go through, you know what? We could do the product rule here, but let's distribute this before we take the product. So that'd be v to the 11th plus 3v to the 6th. We distribute the negative 5. We get minus 5v to the 5th minus 15. So this we could just straight up take the derivative. It'd be 11v to the 10th plus 18v to the 5th minus 25v to the 4th, and then 15 would go away. What are we looking here? Would that be C? All right, find the derivative. Okay, this one we got to do product rule of. All right, derivative of x to the 6th is 6x to the 5th. We'll leave the tangent alone. Then we'll leave the x to the 6th alone. Derivative of tangent is the secant squared. All right, putting it in descending terms, I guess that would be A. Yeah, choice A. All right, ooh, this problem here, we got to do low d high minus high d low over low low, quotient rule here, and it looks like it's going to be fun. So let's see, low, 1 minus cosine x. D high, the derivative of cosine is negative sine of x. Then minus high, 1 plus cosine x. The derivative of the bottom negative cosine x goes to a positive sine of x. And then all over low low, 1 minus cosine of x squared. Ooh. All right, let's distribute the negative sign to both of those to see if any of these answers work. Negative 1, or 1 times negative sine is negative sine. Negative cosine times negative sine is a positive cosine sine. And then let's see, we got to distribute the negative and the sign here, so we get a negative sine of x and then a negative cosine x sine x, which is all over 1 minus cosine x squared. Okay, those cancel out. And so we got minus sine x, so we got minus 2 sine x over 1 minus cosine of x squared. All right, so that looks just like D. I'm going to say that is, unless there's some weird trig identity that I forgot about. All right, next, f of q equals f of x divided by g of x, find q prime of 5. So we got to do low d high, high d low. So we got low, so we got g of 5, d high, f prime of 5, minus high, f of 5, d low, g prime of 5, all over low low, so whatever g of 5 is squared. All right, so let's mark a point at 5 here and here. So remember, the primes are the slopes, the regulars are the y values. So what is the y value of 5? A g, that looks like 4. What's the slope of that? That would be flat, that's 0. Minus, what's the y value of this? I would say that's 6. And what's the slope of this one here? It looks like this is going up 1 over 2. So this is about a slope of a half. All over 4 squared. So we'd get 0 minus 3, or just negative 3 over 16. Is negative 3 over 16 a choice? It is. That's C. All right, next. Find the value of the derivative of the function. So we need to take the derivative of this and plug in 2. All right, so we got low. Actually, you know what? We can divide these. This would become t squared plus 2t to the negative 1 power. The derivative of that is 2t minus 2t to the negative second, or just 2t minus 2 over t squared. That's a whole lot easier to plug in -2. So what's 2 times -2 minus 2 divided by 2 squared, or -2 squared? Not going to change too much. So we get -4 minus 1/2, right? And that is -9/2. That is choice A. You could have done low D, high D, low, and got the same answer. There we go. Going through this review pretty quickly. It is review. Oh, wrong button here. All right, determine the values of x, if any, at which the graph of the function has horizontal tangent. So horizontal tangent would take the derivative, set it equal to 0. All right, this one here, we got to do the quotient rule with the chain rule in it. All right, so let's get this started. Should be fun. All right, we got low, which is x minus 4 squared. D high is 3. Then minus high, 3x. D low, got to do the chain rule. So we got 2 of the x minus 4 to the first power, then times the derivative of the inside, which is likely just 1, all over low, which is x minus 4 to the fourth. All right, so if we look, we have an x minus 4 and both of these in the top, which we can factor it out if we drop this down at the bottom to 3. So let's distribute the 3 here. We get 3x minus 12. And then that went away. We just got to do 3 times 2 times 1, or 3x times 2 times 1, which would be minus 6x over x minus 4 to the third power. So we got minus 3x minus 12 over x minus 4 to the third power. We're going to have to go ahead and plug in, or we're going to set this equal to 0. One thing, we have a denominator, so that means x cannot equal 4. So we get that as an answer. It will not work. All right, we're going to set the top equal to 0. So negative 3x minus 12 is equal to 0. So that means negative 3x would equal positive 12. And that means x would equal negative 4. So there is our point, our horizontal tangent, and we can always double check this on Desmos. So that'd probably been a lot easier to do if you had no idea. Plug it into Desmos, see where it looks like it's flat. All right, use the quotient rule to take the derivative, differentiate. Ooh, it's a hard word for me to say. All right, we got low. T squared plus 3, D high would be 1, minus high, 7 plus T, D low, which would be just 2T, all over low, T squared plus 3 squared. All right, distribute the 1. We got T squared plus 3. We distribute the negative and the 2t, we would get a negative 14t minus 2t squared, or t squared plus 3 squared. So let's combine this. We would have a 3 minus 14t, and then combine this, that'd be just minus t squared over the low. And is that what we got for B? Yeah, not A, because that's a negative sign. B looks good. What about C, D? C, no. D? Oh, it would be a minus. I'm saying it's B. All right, use the quotient rule. So another low D, high D, low. Let's get it started. So we got low, which is T squared plus 4. D high, derivative sign is cosine. And then minus high, sine of T. D low, which would be 2t, and then all over low is just that t squared plus 4 squared. All right, we'll distribute the cosine here, and we get t squared cosine t plus 4 cosine t, and then minus 2t sine of t, and then all over low. All right, it's not a because that's not squared. Okay, next. Well, the only thing here is we could factor out, I guess, the cosine t from both those and get a t squared plus 4 cosine t, which that one's good, that one's good. It is not D because it's not minus. And then it's a minus sign, so that would be B. It's the only thing that left that would make sense. All right, find the derivative. All right, we got chain rule. Actually, we got a lot of chain rule going on because we got 4 plus e to the 2x power to the 1/2. So we're going to take the derivative of something to the 1/2 would be 1/2 of that something to the negative half power. Then we got times by the derivative of the inside. The derivative of the inside, we got to use the chain rule. The 4 goes away, but e to the 2x is a chain rule problem itself. So the derivative of e to anything is just e to that something. Times by the derivative of the inside, or the 2x, which would be 2, which is nice because that cancels out the 1/2. And so really we have e to the 2x and then over the square root of 4 plus e to the 2x. So what is that, a? Yeah, a. All right, next chain rule problem. All right, piece of cake chain rule, because something to the 7th power would be 7 of that something to the 6th power, and then we'll times by the derivative of the inside. The derivative of the 3 goes away, be a negative. What is that? 6 times 4, that's 24t to the 3rd power. So we can multiply this 7 times negative 24, and grab a calculator because I'm feeling kind of lazy today. And we get a negative 168 t to the 3rd power times 3 minus 6 t to the 4th, and that's all to the 6th. So that looks like choice D. Keep it going, find the derivative. All right, this one here, we have to do the product rule because it's x squared times that, which we'll have to do the chain rule of as well. All right, so x to the 8th would be 8x to the 7th. We're going to leave the 4 plus 7x, all of it cubed alone. And then we'll leave the x to the 8th alone. Got to do the chain rule here. So we got 3 of the 4 plus 7x squared, times by the derivative of the inside. I'm in my head here. Derivative of 4 plus 7x is just 7. So we got 8x to the 7th times 4 plus 7x cubed plus, all right, we can multiply those. That'd be 21x to the 8th times 4 plus 7x squared. Oh, geez. So what do all these have in common? Well, we can factor out an x to the 7th, right? And a 4 plus 7x squared. That's what all of these have in common. All right, so what's left over here? We would have just left here just the 8 times the 4 plus 7x, one of them left over. And then here, that goes away. We would have 21x. That'd be it. All right, so does that simplify? Yeah, I'm sure it does. All right, distribute this 8 to both of those. So 8 times 4, that's 32, plus 56. Wait, yeah, 8 times 7, that's 56. Yep, plus 21. All right, we can combine those x's here. So which problem would it be? It'd be 32 plus 77x, and it'd be x to the 7th. So that'd be choice D. All right, derivative. Chain rule again, cosine of something. Well, the derivative of cosine is negative sine of that something. And we times by the derivative of the inside, that would be 15x to the 4th. All right, we can multiply that times the negative outside, so we have a negative 15x to the 4th, sine of the inside, and that looks like choice B. All right, this one here, we do have another chain rule, because it is sine of 2x, so negative 6 sine, or negative 6 sine would always be negative 6 cosine. We'll leave the 2x alone. Now times by the derivative of the inside would just be 2. We can multiply the 2 times the negative 6. That'd be negative 12 cosine of 2x. That'd be B as well. All right. Next, natural log. Natural log is 1 over x, but since it's one natural log of something, it's going to be 1 over that something. All we got to do is times by the derivative of the inside, which would be 14x minus 4. All we can do is just move that on to the top. Nothing factors out here, and that would be choice C. Yeah, 14x minus 4. All right, 16. Here we go. All right, the position of an equation is given by the particle where s is measured in feet. Find the acceleration when t equals 2 seconds. So if we have the position, the derivative would tell us the velocity. I'm going to change the t cubed plus 1 to the half power. So let's take the derivative to get the velocity. That would be 1/2 of t cubed plus 1 to the negative 1/2 power, and then we times by the derivative of the inside, that'd be 3t squared. So we get 3/2 t squared times t cubed plus 1 to the negative 1/2 power. All right, if we want to find the acceleration, we got to do the derivative of that, which means we got to do the product rule. All right, so acceleration. All right, 3/2 times t squared, or 3/2, so we'll times it by 2, it would just be 3t. We'll leave the t cubed plus 1 to the negative 1/2 power alone. And now we'll leave the 3/2 t squared alone, times by the derivative of the inside, which we got to do the product rule, so it'd be our chain rule. Negative 1/2 of t cubed plus 1 to the negative 3/2 power, times by the derivative of the inside, which would be 3t squared. All right, so we'd get 3t times t cubed plus 1 to the negative 1/2 power plus, okay, let's see, we can multiply. Actually, that'd be minus now. We got 1/2 times 3/2 times 3. All right, so that'd be, let's see what's on top. 3 times negative 1 times 3. That'd be negative 9. I've already got the negative sign there. Let's clean this up. Too much scratching out. So minus 9 over 2 times 2 times 1 is 4. T times t squared is t to the 4th, and then we have t cubed plus 1 to the negative 3/2 power. All right, should we, I guess we could, but what we need to do is just plug in. We could make this look neater, but we got to plug in 2 now. So let's plug, let's make it neater. Let's get brighter. Let's factor this negative 3/2 power out. So that would be on the bottom, t cubed plus 1 to the 3/2 power. And let's see, if we factor out, that'd be 3t times t cubed plus 1. And this would just be minus 9/4 t to the 4th. And so this would be, all right, we can distribute this here. Be 3t to the 4th plus 3t minus 9/4 t to the 4th. And so finally, here we go. This would be, what's 3 minus 9/4? 3 minus 9 divided by 4 is 0.75. So that is 3/4 t to the 4th plus 3t over t cubed plus 1 to the 3/2 power. Okay, now we got something that's a little bit easier to plug into. So what's 3/2 of 2 to the 4th plus 3 times 2 divided by 2 to the 3rd power plus 1 to the 3/2 power. All right, let's try to figure this out. 2 to the 4th power is 16. 16 times 3/2. 16 divided by 2 is 8. 8 times 3 is 24. Plus 3 times 2 is 6. Now on the bottom here, 2 to the 3rd power is 8 plus 1 is 9. The square root of 9 is 3. 3 cubed is 27. And so I get like 30 over 27, and that isn't making sense. So I made a mistake somewhere. See if I can figure this out. Okay, let's see if I messed up over here. I know this derivative is probably good, so let's see. It does 3 times 2 times 2 cubed plus 1 to the negative 1/2 power. I'm just going to plug in 2 to this. Minus 9/4 times 2 to the 4th times 2 cubed plus 1 to the negative 3/2 power. What does that equal? All right, this would be 9 to the negative 1/2 power. That'd be 1/3. That goes away, so that'd just be 2. And then minus, all right, let's see. What did 9 to the negative 1.5 power? What is that? 9 to the negative 1.5 power. That is, math, enter, negative 1/27. And let's see, times 9 divided by 4 times 2 to the 4th power. That'd be 4/3. All right, what's 2 minus 4/3? All right, still getting it. Wait, no, 2 minus 4/3, that's what it is, 2/3. And there's the answer. All right, so I made a mistake simplifying this here, but the answer is 2/3. These are definitely tougher problems than what are on the exam. I'll put the tough ones on the review. All right, find dy dx. Okay, so this, if you were in 2020, you did not go over this one here, but anything after 2020, we're going through. All right, we got to do the chain rule here. So if we do the chain rule, natural log of something is 1 over that something. And then we need to times by the derivative of the inside. The derivative of the inside, we have to do the product rule of, since it's x times y. Our derivative of x is 1. We'll leave the y alone. Next, we'll take the derivative of y, or leave the x alone. Derivative of y is dy dx. Next, okay, we got to go over here. The derivative of x is 1. Derivative of y is dy dx. Now we need to get the dy dx by themselves. So if we distribute this 1 over xy, y times 1 over xy is just 1 over x. X times 1 over y is 1 over y. We got a dy dx. And then equals 1 plus dy dx. All right, let's move everything that has a dy dx to one side, everything that doesn't to the other side. So we get 1 over y dy dx plus dy dx is equal to 1 minus 1 over x. We need to factor out the dy dx. And we get a 1 over y plus 1. Oh, not equals 1 over 1 minus x. All right, so we'll divide. So dy dx is equal to 1 minus 1 over x over 1 over y plus 1. All right, we got to figure out what answer matches. All right, if we want to combine these, we got to get common denominator. So this would be y over y, and this one would be x over x. And so we get x minus 1 over x divided by 1 plus y over y. So really have x minus 1 over x and then multiplied by y over 1 plus y. All right, if we distribute the y on the top, we get xy minus y. Distribute the x on the bottom, x plus xy. Or is it minus? It should be minus. All right, so that would be choice B. All right, next, dy dx here. All right, what happens to the x? It becomes 1. Next, take the derivative tangent, which is secant squared. Let's try that again. Secant squared. Leave the inside part alone. Then we'll times by the derivative of the inside, which becomes 1 plus dy dx. All right, if we want to get this by itself, first thing we need to do, let's divide by the secant squared. So 1 divided by secant squared of x plus y, and then equals 1 plus dy dx. All right, we need to subtract the 1 over. All right, and so we probably get a weird trig rule. All right, we get 1 over secant squared of x plus y minus 1 equals dy dx. All right, if we wanted to get common terms, we'd have to make this 1 minus secant squared of x plus y over secant squared of x plus y. All right, there's probably a weird trig identity here. Let's see, secant is 1 over cosine. So this is 1 minus 1 over cosine over 1 over cosine. And so that'd be 1 minus 1 over cosine squared times cosine squared. So this would be cosine squared minus just cosine. Oh, that probably simplifies down to something. Yeah, I'm not really even sure right now. Let's take a guess here. This is tough. I'm guessing it'd be, no, it's not D. It's either A or, I'm guessing A. I'm not sure though. Definitely tougher, these trig identities here. This one we can go over here. All right, derivative of x squared would be 2x. Derivative of 7 is 7. Now 5xy, we got to do the product rule. So 5x is 5, we leave the y alone. Next we'll leave the 5x alone, and that's dy dx. And then minus y squared is 2y, dy dx. Derivative of 9 is 0. All right, anything that doesn't have a dy dx, move it over to the other side, and then we're going to divide by what's on the dy dx. So we would get a negative 2x minus 7 minus 5y over a 5x minus 2y. Now, if we want to make these positives, we just need to switch the order here. So make it a 2y minus 5, and that looks like C would be the right choice. All right, one more problem to go. We'll be done here. All right, next problem here. All right, we got x to the 6th power, which would be 6x to the 5th plus derivative of 5x is 5. 13xy, let's see, that'd be 13. We got to do the product rule of, leave the y alone, plus 13x. Now we take the derivative of y, which is dy dx. And then minus, okay, what about y to the 5th? Be 5y to the 4th dy dx. And that would equal 0. So just like the other one, we're going to move these all over to the other side and divide by that. So everything would be negative. Negative 6x to the 5th minus 5 minus 13y over 13x minus 5y to the 4th. If we want to make these all positive, we switch the order. So it looks like B would be the choice here. All right, how well did we do? Did I mess up on a couple of them? It says submit one anyways. Okay, I probably left them on blank. We'll see how we did. 18 out of 20. Which one did we mess up on? There's the one we guessed. Oh, doing good so far. All right, 16. Did we not guess? Oh, we left it blank. Oh, unanswered. So yeah, that one was 2/3. And then did we leave this one blank? Oh no, we said A, and that's right. This one here, what did we mess up on? Did I get tricked up on something? Oh, maybe one of them are negative. All right, well, we see that. Remember, if you guys do these and get a good score, I will curve your exam score. So kind of bonus for you guys. All right, best of luck. I will see you next time.